It rises from the marshes of South Texas like a cathedral built by a civilization that has already conquered the stars. This is not a launch pad. This is a machine that builds other machines. A vertical assembly line taller than the Statue of Liberty. Inside these walls, physics is being bullied into submission. Metal is bent, frozen, and ignited until it learns how to fly. They call it Mechazilla, a structure designed not just to launch rockets, but to catch them out of the sky with the precision of a surgeon. For 50 years, building a rocket was a handcrafted art form, slow, expensive, precious. But here it is war. We are looking at the most powerful flying object ever created by humanity. Twice the thrust of the Saturn V, fully reusable. But the true revolution isn't the fire, it's the steel. The decision to abandon high-tech carbon fiber for the same material used in kitchen sinks. Every piece of this architecture screams one word: scale. We aren't building a rocket, we are building a fleet. Welcome to the rocket garden, the only place on Earth where spaceships are grown like crops in a field of steel. The sound you hear is the heartbeat of a new era. A Methalox scream that signals the end of gravity's tyranny. It feels cold to the touch. It feels impossible. And yet, they are welding a new one every single week. Speed is the currency here. While NASA spends a decade on a single chassis, this factory churns out Leviathans in days. They aren't building this in a sterile lab. They are building it in tents, in the dirt, exposed to the elements. It looks like madness. One man's obsession turned into an industrial juggernaut. A bet of $10 billion on a simple idea. Humanity must not die on Earth. The goal isn't orbit. The goal isn't the moon. The goal is a second home. But before we get there, we have to master the cold. The sub-zero temperatures that shatter ordinary metal like glass. And the heat. 18,000 distinct ceramic tiles, forming a black armor against the atmosphere. The infrastructure alone is an engineering marvel that rivals the pyramids. The dust is settling. The stage is set. But to understand the miracle of this factory, we have to understand why the old way of doing things was doomed to fail. Imagine flying a Boeing 747 from New York to London, and then throwing the plane into the ocean. For 60 years, this was the business model of spaceflight. We built masterpieces of engineering, flew them once, and destroyed them. Even the space shuttle, promised as reusable, required billions in refurbishment. It was a Ferrari that needed a complete engine rebuild after every trip to the grocery store. This created a culture of extreme caution. If you can't afford to test, you analyze. You spend years in meetings, afraid to turn a wrench. It was fueled by cost-plus contracts. The longer you took, and the more money you wasted, the more profit you made. Inefficiency was incentivized. The result? Rockets that cost $2 billion per launch. A price tag that kept humanity grounded, dreaming of stars we couldn't afford to visit. Musk initially tried to play by their rules. He spent millions trying to build Starship out of high-tech carbon fiber. But it was slow, it was brittle. It cooked slowly in the oven, and if you made a mistake, you scrapped months of work. He didn't have years. He needed a material he could weld in a field. He needed something stupidly simple. Stainless steel. The same alloy used in pots, pans, and brewery tanks. It was heavy, it was cheap, and the experts laughed. You can't build a rocket out of steel, they said. It's too heavy, the mass fraction won't work. So he went to a water tower company. Not aerospace engineers, welders who built water tanks. And in a muddy lot in Boca Chica, they started welding rings together. It looked like a junkyard project. But then the water tower flew, and the laughter stopped. The industry realized too late that they weren't competing against a rocket. They were competing against a philosophy. Old space says, measure twice, cut once. SpaceX says, cut 10 times, weld it back together, blow it up, and learn why. They treat explosions not as failures, but as data points. Expensive data points, but fast ones. This philosophy is the only way to bring the cost down from billions to millions. But a philosophy is nothing without a factory to execute it. Let's go inside the machine. Why steel? It comes down to cryogenics. Most metals get brittle when frozen. Steel actually gets stronger. When you load super-chilled propellant, the hull becomes tougher. It doesn't need heat shielding on the way up, only on the way down. And on re-entry, aluminum melts at 1200 degrees. Steel survives until 2600. It is its own heat shield. Then there is the heart of the beast, the Raptor, a full-flow staged combustion engine. For decades, this cycle was considered the holy grail of rocket science. The Russians tried, the Americans tried, everyone failed. It was too hot, too complex. It requires turbines spinning at hundreds of times per second, handling pressures that would crush a submarine. The secret sauce? Methane, natural gas, the same stuff in your kitchen stove. Old rockets used kerosene. It's dirty. It leaves soot in the engine like a clogged artery. You can't reuse a clogged engine. Methane burns clean. You can fire it, land, refuel, and fire again immediately. It is the fuel of reusability. And crucially, you can make methane on Mars. You can't mine kerosene there. If you want to come home, methane is the only choice. But steel and methane aren't enough. The ship has to survive the atmosphere screaming at Mach 25. This creates a plasma sheath hotter than a welding torch. Any gap in the armor is death. To slow down, it does something crazy. It falls belly first. Skydivers do this to increase drag. Rockets never do this. It uses these massive flaps not as wings, but as air brakes. It is literally surfing the atmosphere. Then, at the last second, the suicide burn. It kicks the tail out, lights the engines, and catches itself. It's like trying to balance a broomstick on your hand while falling out of an airplane in a hurricane. The software required to keep this unstable pendulum upright is just as impressive as the steel. Back in the factory, they are printing engine parts, not casting them, printing them. This allows for internal cooling channels that would be impossible to machine. The engine cools itself with its own fuel. The assembly process is modular. They build rings, stack them into cans, and stack the cans into ships. It's a continuous spiral of welding, a never-ending ribbon of steel. They test these welds to destruction, over and over again, until the math matches reality. Look at the evolution. Raptor 1 was a mess of pipes. Raptor 3 is clean. They deleted the parts that didn't need to exist. The best part is no part. If it's not there, it can't break, it costs nothing, and it weighs nothing. Now, let's see how they turn this science into an assembly line. Starbase, Texas. A few years ago, this was a swamp. Now it is a 24/7 hive of activity. 3 shifts, round the clock. The factory never sleeps. The light of the welding torches is the lighthouse of the Gulf. They outgrew the high bay, so they built the mega bay, a building designed to hold multiple rockets at once. This is the goal, an assembly line. Not one rocket every year, one rocket every few days. In Hawthorne, California, the engine production is equally relentless. They are producing a Raptor engine every single day. This is the Henry Ford moment for spaceflight. We are moving from the artisan era to the mass production era. When a ship is finished, it takes a road trip. These self-propelled modular transporters carry the beasts down Highway 4 to the launch site. Imagine driving to work and waiting at a traffic light for a skyscraper to cross the road. The launch site itself is a beast. The orbital tank farm holds millions of gallons of cryogenic propellant. The quick disconnect arm. It fuels the rocket and detaches milliseconds before liftoff. It creates a bridge between Earth and sky. Under the mount, a massive steel showerhead, the deluge system. It blasts tons of water upwards to dampen the acoustic energy. Without it, the sound waves alone would tear the concrete apart. Back in the factory, the dance continues. Gantry cranes moving 100-ton sections with millimeter precision. Boston Dynamics robot dogs patrol the facility, scanning welds and monitoring safety. The future inspecting the future. The factory runs on Starlink. The rockets launch Starlink. It is a self-feeding ecosystem. Manual labor is the enemy of speed. If a robot can place a heat tile, a robot will place the heat tile. It's not all pretty. There is a boneyard of twisted steel, the ghosts of prototypes past. But even the failures are recycled. The steel from a crashed rocket becomes the skin of the next one. There is a savage beauty to this place. It feels like a colony on an alien world, right here in Texas. A community has sprung up around it. People travel from all over the world just to watch a tank get moved. The pace is grueling. The burnout rate is high. This mission demands everything from its creators, but they stay. Because they aren't just building a product, they are building a gateway. This is extreme vertical integration. Raw steel comes in one side, a spaceship comes out the other. The logistics alone are a nightmare. Oxygen, nitrogen, methane, steel, electronics. A river of resources flowing into a point on the map. When they stack the ship on the booster, it stands 400 feet tall, taller than the Saturn V, taller than the N1. Its shadow stretches across the landscape, pointing the way out. Nature and machine, coexisting in a strange harmony. When the propellant loads, the beast wakes up. It breathes. Every test is a roll of the dice. And when 33 engines light, the world shakes. But the road to the stars is paved with debris. We cannot forget the violence of this endeavor. Rapid, unscheduled disassembly, a polite term for a catastrophic explosion. Sometimes, the rocket just vanishes into the fog and metal rains from the sky. Every crater is a lesson, but these lessons cost millions of dollars and thousands of man-hours. The factory floor is a minefield of invisible dangers, high-pressure gas, cryogenic fluids that can freeze a limb solid in seconds. One bad weld, one tiny bubble in the steel. That is all it takes to turn a spaceship into a bomb. And then there is the regulatory pressure, the FAA, the EPA, the struggle to get permission to fly. The first orbital launch tore the concrete pad to shreds, hurling boulders for miles. It was a reminder of the raw energy involved. But they didn't quit. They rebuilt, stronger, with a water-cooled steel plate. The human cost is exhaustion. The relentless cadence of go, go, go takes a toll. The media loves a fireball. They call it failure. They don't see the iteration. Right now it's just steel. But soon there will be people inside. Mothers, fathers, explorers. When humans climb aboard, rapid, unscheduled disassembly is no longer an option. Reliability must be absolute. 99% success rate is not good enough. The cost of failure is high, but the cost of never trying is higher. If they succeed, the math of the solar system changes. Orbital refueling unlocks the solar system. We go back to the moon, not to visit, but to stay. A permanent base on the Sea of Tranquility. On Earth, anywhere to anywhere in 45 minutes, the world becomes a village. And then, the fleet. The launch window opens every 26 months. 1,000 ships departing for the Red Planet. Terraforming. Green valleys on a dead world. The light of consciousness spreading beyond a single candle. A generation born under a different sky, looking back at Earth as a pale blue dot. This factory in Texas is just the prototype, the shipyard for the first interplanetary species. It all starts with a roll of steel and a welder in a tent. The impossible becomes the routine. The routine becomes the standard. There are no guarantees, but for the first time in history, the door is open. We are witnessing the most exciting engineering project in human history. Are you ready to go? Like this video if you believe the age of oil is finally ending. Don't miss our next episode, where we dive into the technology that has potential to change humanity and the world.